assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Let's begin this problem by first identifying which of the circles are cations and which of the circles are anions. A general trend that we should know is that anions tend to be larger than cations. This is generally true if the ions are already similar in size. So of course it's going to depend on which anion and cation you're comparing. Let's compare the anions and the cations in the ionic compounds that we're being asked about in the question. The first ionic compound that we were given is sodium chloride. So let's compare the size of sodium to the size of chloride. We know that chloride must have the larger atomic radius. This is because chloride has one more energy level than sodium. Recall that when a cation is formed, electrons are being taken away. So when sodium loses its electron, it ends up having 2 energy levels instead of 3. In contrast, chlorine has 3 energy levels originally, and when it gains an electron, it still has 3 energy levels. The same logic can be applied when we compare magnesium to oxygen. In this case, magnesium and oxygen both have 2 energy levels. However, since magnesium has more protons, then it's going to have a stronger attraction between its positively charged nucleus and its outer electrons. Because of this stronger attraction, the radius becomes smaller as the electrons are drawn inwards. This makes oxygen the larger. Now that we know that smaller ions tend to be cations, let's just label that on our pictures. So the smaller black dot is going to be a cation in the A, and the larger green dot is going to be our anion. And in B, our larger red ion is going to be our anion, and our smaller blue ion is going to be our cation. So now that we know which is the cations and which is the anions, we can compare the sizes of the cations and the anions in the ionic compounds given to see which match the pictures. So let's start by comparing the cations. If we compare sodium to magnesium, then we know that sodium and magnesium as ions have the same number of electrons. This is similar to when we were comparing magnesium and oxygen. Again, if you have more protons, you're going to have a smaller atomic radius due to a stronger attraction between the electrons and the nucleus. Since magnesium has one more proton than sodium, that makes magnesium slightly smaller than sodium. Next, let's compare the anions. We are comparing chlorine to oxygen. This comparison is a bit easier to make. We know that chlorine has 3 energy levels, as we said before, and we know that oxygen has 2. Therefore, chlorine must be larger. So now we know that sodium and chlorine have larger atomic radii than magnesium and oxygen. When we look at pictures, we see that in A, both the cation and the anion are larger than the cation and anion of B. Therefore, A must be sodium chloride, and B must be magnesium oxide. The next part of the question asks us about lattice energy. Let's recall how to calculate lattice energy. Lattice energy is equal to K, which is a constant, times Q1, which is the charge of one ion in the ionic compound, times Q2, which is the charge of the other ion, over the distance between the ions, which is R. Looking at this equation, we can determine that the product of the charges, which is represented by Q, if it's larger in magnitude, will have a larger lattice energy. In addition, if we have a smaller ionic radii, we have a larger lattice energy as well. So let's compare the relative lattice energies of sodium chloride and magnesium. In sodium chloride, the Q is going to be equal to the charge of sodium times the charge of chlorine, which is positive and negative 1 respectively. So Q is going to be negative 1. In addition, while we don't have the exact value for R, we know that sodium chloride has bigger ions, so the R is larger, at least in comparison to B. Let's do the same thing for magnesium oxide. The Q will be equal to the charge of magnesium plus 2 times the charge of oxygen, which is minus 2. And that gives us minus 4. In addition, we know that R is going to be smaller in comparison to A. Following the trends that we talked about earlier, we know that magnesium oxide has a larger Q and a smaller R, so it must have the larger lattice energy. So that is the answer for the final part of the question.